Math 116, section 1.2, we're looking at functions. So all sorts of things about functions. And I wanted to start off looking at the questions that ask about the domain and the range of a function. So let's look at question number 27, and this is on page 74. I want to help you find the domain and range of a function. Once you get the hang of it, they're sort of straightforward. So here's our problem. We have y equals x squared plus 4. And the question says find the domain and the range for each of the functions. So the domain is all of the x values. So what can the x values be? So basically you say, well, can you plug any value in there and square it? Sure. There's no restriction on the numbers that we can square. For example, we could have -1 squared or -1.257, I just made that up, squared, or even I, an imaginary number, squared. So the domain is all real numbers. And the range is the values of y. So what values can y take? Well, here's the problem. So this number is always going to be positive. So it's going to be, even if it was a negative number, that's going to be positive. So the smallest value there is going to be 0. So y is going to be anything bigger. So if x was 0, then y is going to be 0 plus 4. So the very smallest value that y can take is 4. So y is going to be anything from 4 on up. So y is all y's greater than or equal to 4. And I'm going to show you a picture. You can graph this to see. This is that online graphing calculator. Y equals x squared plus 4. I hit graph. Bang! I can zoom in a little bit, like this. So you can, oops, let me zoom out. So you can see that x can be anything, kind of go along here, that'll go up forever. So x can be any of these numbers. If I picked some number up here, I'd have to go really high before I hit the top of that parabola, but I'd get there. But there's a whole bunch of areas of this y value here where this parabola is never going to hit it. So the y values are from 4 on up, and the x values can go anywhere. So that's why the domain is all real numbers and the range is y greater than 4 with the real numbers. You're not going to get an imaginary number with this one. Okay, let's look at another one. Let's look at number 29. So this is question number 29, and we have y equals square root of x plus 4. And again, the problem asks for the domain and the range. That is, what are the x values, or what are the values that x can take on, and what are the values that y is going to take on. So if you look at this, these square roots are restrictive because you cannot have the square root of a negative number. That is no good. So we know we want, for the domain, for the x values, domain is the x values, we want x plus 4 greater than or equal to 0. You can take the square root of 0, that's fine. So this can be 0, it just can't be a negative number. So this equation implies that we want x, if you subtract 4 from each side, x greater than or equal to -4 as the domain. And because the range, it says what values of y can this take on? Well, y is always going to be a positive number. Again, you can think the smallest value of y, if x is 0, or if x is -4, you're going to get y is 0. So it's possible that y could be 0, but it's not going to be less than 0. So y is going to be everything greater than or equal to 0. And if you wanted to, you could think of this as plug in the x equals -4 value here, and you get y equals square root of -4 plus 4 equals 0. So the lowest value of y is going to be 0, and then as x goes on up, y is going to go up too. You can also graph this and see. Here I have this equation. This is the old one. I'm going to graph the new one. Ta-da! So you can see the x values. Here's the x line. X has to be greater than -4. So -4 on up is okay, and y has to be greater than 0. You'll notice there's no y values down here, and there's no x values past -4. So again, the domain is x greater than -4, and the range is y greater than 0. Range that. Domain there. Domain. Range. Okay, now let's look at another problem. A cost problem. Okay, so this is question number 51, and it says the cost of producing a product is given by C of x, the cost for x, is equal to 300x plus 0.1 x squared, so 0.1 times x squared, plus 1200. And as you go through this book, there are a lot of cost functions, so that's why I wanted to call this problem to your attention. And part A says find the total cost of producing 10 units. So what is the total cost for producing 10 units? And in this case, x is equal to the number of units. That's often how it works with these cost functions. X is equal to the number of units. So if the total cost is x equals 10, we're looking for total cost when x equals 10 is equal to, we're going to plug 10 into this equation. So 300 times 10 plus 0.1 times 10 squared plus 1200. And now we plug it into our calculator. This is 3,000 plus, this whole thing turns into 10. What? 100 times 0.1 plus 1200 equals 42. 10. I transposed it in my mind. So the total cost of producing 10 items is $4,210. That's the total cost for 10. So then part B says, what's the value of C of 100? So we're going to do the same thing, plugging in 100 into this equation. I'll make it all red this time. So we have 300. Every place there's an x, I'm going to plug in 100. Plus 0.1 times 100 squared plus 1200. This is equal to 4 zeros. Plus, that's 30,000, plus 1,000. That's 0.1 times 100 squared plus 1200 equals 32200. And what is this saying? This is saying this is the cost, the total cost to you if you're producing all these things, of producing 100 items. So if you're my mom and it costs you that much, $4,000 to produce 10 scarves, then it's going to cost you $32,200 to produce 100 scarves. My mom makes scarves. They're not that expensive though. So this is how you do that. So look for more of these cost functions as you go through this book. We're going to do a lot of them.